Section 2.3, Observational Studies and Experiments. Objective 1, identify the components of a good study. A doctor wanted to test the effect that marijuana has on the side effects of chemotherapy for cancer patients. One way to test this would be to give 200 cancer patients marijuana to smoke after going through chemotherapy. Suppose that of these 200 patients, 80% felt relief from side effects of chemotherapy within a few hours. From this, is the doctor able to conclude that marijuana helps with side effects of chemotherapy? Definition: each treatment group in a study is a collection of individuals who receive a certain treatment. The control group is a collection of individuals who do not receive any treatment. It is important that these two groups are treated as similarly as possible. To ensure this, the control group is typically given a placebo, which is a fake drug like a sugar pill that has no effects but tastes and looks like the actual treatment drug. Another definition: the population of a study or experiment is the entire group of people we wish to learn about. The sample of a study or experiment is the group that we use to be a part of our experiment or study. So, for example, from the example above, discuss how the experiment can be altered so that there is a treatment group and a control group. Then describe the sample and the population of the experiment. Well, that example has 200 patients, and we have a treatment, which would be the marijuana, and then we have the control, which is the placebo. So the sample is going to be 200 cancer patients, and the population would be all cancer patients. So again, what is the treatment for this example? The marijuana. The control group is the placebo. Again, the sample is the 200 cancer patients that were selected, but the population would be all cancer patients. Another definition here: the placebo effect occurs when the characteristic of interest changes in individuals due to the individuals believing the characteristic should change. Another definition: in a single blind study, individuals do not know whether they are in the treatment groups, or the control group. In a double-blind study, neither the individuals nor the researcher in touch with the individuals know who is in the treatment group or groups and who is in the control group. Example: identify components of a study. In a 2008 study, researchers attempted to determine whether dark chocolate and cocoa improve mental and heart health in older, healthy, alert adults. Out of 90 healthy, alert adults at least 60 years old, 45 participants consumed dark chocolate bars and cocoa drinks, and 45 participants consumed similar fake chocolate products, both on a daily basis for 6 weeks. To keep the participants and researchers from knowing which products the participants were consuming, an independent researcher randomly numbered the containers of the products, and for each container recorded whether the products were made with real or fake chocolate. The researchers did not find evidence that dark chocolate and cocoa improve mental and heart health in older, healthy, alert adults. So number one, we want to describe the sample in the population. Well, if we take a look up here, there were 90 healthy, alert adults that were chosen. So therefore, the sample consists of 90 participants. The population would consist of all healthy, alert adults at least 60 years old. Number two, describe the treatment and the control groups. Well, the treatment group consists of the 45 participants who consumed dark chocolate bars and cocoa drinks. The control group consists of the 45 participants who consumed fake dark chocolate bars and fake cocoa drinks. Number three, it says that the title of the journal article says that a placebo was used. What is the placebo? Well, the placebo is the fake chocolate products. Number four, the title says the study is double-blind. Why does that make sense? Well, the study is double-blind because neither the participants nor the study's researchers knew which participants consumed which products. Next definition. Random assignment is the process of assigning individuals to the treatment groups and the control group randomly. Example, perform random assignment. A researcher wants to test whether pre-statistic students perform better on their homework if they do it while listening to hip-hop music. The researcher randomly selects the 16 students shown in the table 25 here, use the seed 772 to randomly select 8 of the students for the treatment group. The other 8 students will be in the control group. So here's our table that lists the 16 students. And so recall that even with the same seed, different technologies may give different random numbers. So in this case, we want to enter the seed as given in the problem, 772, into the TI-84 calculator. And then we randomly select 15 numbers between 1 and 16 inclusive. And we select 15 numbers rather than just 8 in case there are repeats. So let's go ahead and do this on our calculator. All right, so we're going to first take our seed, which is 772. So we're going to go ahead and put in 772, and then we're going to use our store button here. And then we're going to go to the math option in our calculator, and then scroll to the PRB, which is probability. And then we're going to hit the R and selection. So we're going to hit enter. And then you're going to select enter on this option. So therefore it's going to keep that seed so that we can select it accordingly. Now, the next step is that we want to be able to then find the prompt to be able to find these numbers. So we're going to go back to the math option, and then again scroll to the right where you see probability, PRB, and we're going to go down all the way to number 5. So we're going to go all the way to number 5. It says R and INT. So we're going to go ahead and do that. And then we're going to put the numbers of students. So we start with 1 student, and we're going all the way to 16. And then we're going to go ahead and choose 5. We're going to put in 5 and then close the parentheses. So it's going to give us 5 numbers. So the first 5 numbers you see are 10, 13, 16, 4, and 2, which is great because none of them are repeating. But that only gives us 5 numbers. We want 8 numbers because that's how many students that we're wanting to select. So we'll just hit enter again. When we hit enter again, we see the number 9, but then 13 is a repeating number, 2 is a repeating number, and so is 4. So you can see here that we're selecting only ones that are colored. So we got 9 and then 5. Now we're going to have to hit enter again. When we hit enter again, we see that 2 is repeating again and 10 is repeating again until we get to 14. So what that tells us is that from the calculator, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers that now we can select. So the selected numbers, as the entire selected numbers that was given in the display were 10, 13, 16, 4, 2, 9, 13, 2, 4, 5, 2, 10, 14, 16, and 7. The first 8 numbers without repeats, which are in red, are 10, 13, 16, 4, 2, 9, 5, and 14. So the following 8 students would be the treatment group. So we would go ahead and then let's highlight those students. Well, we know that 10 is Donovan. We know that the 13th student is Alejandra. We know the 16th student is Jaime. We know that which one is the next one? We know that the 4th student, or number 4, is Gregory. Number 2 is Trenton. Number 9 is Nicholas. And number 5 is Jacqueline. And number 14 is Kevin. The other 8 students should be in the control group. Now, components of a well-designed study. In a well-designed study, there should be a control group and at least one treatment group. Individuals should be randomly assigned to the control and treatment groups. The sample size should be large enough. A placebo should be used when appropriate, and the study should be double-blind when possible. If this is impossible, then the study should be single-blind if possible.